Welcome back. This video is an introduction to the concept of the sampling distribution. This concept is going to be important in our future topics in our class. You might not fully understand its importance in this video, but that's okay. This video is just an introduction to the concept. So as long as you understand the main ideas that I'm presenting, then that's fine for this video. So let's start with the definition of a sampling distribution. A sampling distribution is a distribution of possible samples in a random sampling situation. Let's go straight to an example because I think the definition will become more clear once we look at an example. So I created some visuals right here. This is our first example of a sampling distribution. Remember I said that a sampling distribution is a distribution of possible samples in a random sampling situation. Right here we have an imaginary population of 4 people. Each person has his or her own age. We have a 20-year-old, a 30-year-old, a 40-year-old, and a 50-year-old. We're imagining that 2 people are being randomly selected from this population. They're being selected in some random way. Maybe someone is putting 4 pieces of paper into a hat and shaking it up and taking out 2 pieces of paper. Or maybe someone is using a generator to select 2 random people. It's just a random sample of 2 people being selected in some random way. After the 2 people are selected, the 2 ages are recorded and the sample mean is calculated. The person who selects the 2 people records their 2 ages and then adds the 2 ages and divides by 2 and gets the mean of the 2 selected people. Now we don't know what this sample mean is going to come out to. There's more than one number that it could come out to. That's because the number that the sample mean comes out to depends on which 2 people are selected. If person 1 and person 2 are selected, the sample will have a 20-year-old and a 30-year-old. 20 plus 30 equals 50, divided by 2 equals 25. That means that if person 1 and person 2 are selected, the sample mean will be 25. If person 1 and person 3 are selected, the sample will have a 20-year-old and a 40-year-old. 20 plus 40 equals 60, divided by 2 equals 30. If person 1 and person 3 are selected, the sample mean will be 30. Like I said, the number that the sample mean comes out to depends on which 2 people are actually chosen. We can make a diagram over here showing each possible sample of 2 people that might be selected, and we can plot each possible sample above its sample mean. Right here we have person 1 and person 2. That's one possible sample of 2 people. Their mean is 25 because it's if we look back up here in the population, we see that this is a 20-year-old and a 30-year-old. So 50 divided by 2 is 25. Person 1 and person 3 are another possible sample of 2 people. This includes a 20-year-old and a 40-year-old. You can see that up here. Their mean is 30 because 20 plus 40 equals 60, divided by 2 equals 30. There are 2 possible samples that have a mean of 35. Person 1 and person 4 are a 20-year-old and a 50-year-old. So 20 plus 50 is 70, divided by 2 is 35. These 2 people have a mean of 35. Person 2 and person 3 are a 30-year-old and a 40-year-old. 30 plus 40 equals 70, divided by 2 is, once again, 35. So there are 2 ways to get a mean of 35. If person 1 and person 4 are selected, the mean will be 35. If person 2 and person 3 are selected, the mean will be 35. There is one possible sample with a mean of 40. Person 2 and person 4 are a 30-year-old and a 50-year-old. 80 divided by 2 is 40. Person 3 and person 4 are the last possible sample. They're a 40-year-old and a 50-year-old. 90 divided by 2 is 45. So we have 6 possible samples, which are basically just the 6 possible combinations of 2 people. And each possible sample, each combination, has its own mean, its own average. And when we plot the possible samples above their sample means, we get something called the sampling distribution. This diagram right here is the sampling distribution for this random sampling situation. It's the distribution of possible samples for this random sampling situation in which two people are being randomly selected from this population, the ages are being recorded, and the mean is being calculated. You can think of it this way. In this random sampling situation, it's like a person spinning a wheel or a spinner, and the spinner is going to land on one possible sample. And the possible sample that the spinner lands on is the actual sample. It's the actual two people who were actually chosen. Over here, we're spinning a wheel, we're spinning a spinner, and then that spinner is going to land on one of these boxes. The box that it lands on is the actual two people who were chosen. So if the spinner lands right here, these two people are chosen, the mean is 40. If the spinner lands here, these two people are chosen, the mean is 25. And I like the spinner analogy. I think it captures the concept pretty well. It kind of helps describe this concept in a simple way. So that's why I shared that analogy. We can also see in this diagram that the sample mean has to come out somewhere between 25 and 45. It can't come out any lower than 25, and it can't come out any higher than 45, because the possible samples go from 25 to 45. At this point, you might be wondering why this concept is useful, or how this concept could be used to solve any type of problem. Well, and I'll answer that question. This sampling distribution can be used to find probabilities. That's actually the main purpose of a sampling distribution, is to calculate a probability. We can use this sampling distribution to calculate the probability of each of these numbers down here on the x-axis. So let's start with the probability that the sample mean will come out to 25. There are 6 possible samples, and one of them has a mean of 25. That means that there is a 1/6 probability that the two people who are actually chosen will have a mean of 25. That's because the only way for the mean to come out to 25 is for these two people to be chosen. And they're just one combination out of 6 combinations. So there's only a 1/6 probability that the sample mean here will come out to 25. There is also a 1/6 probability that this sample mean will come out to 30, because 1 out of 6 possible samples have a mean of 30, right? There is a 2/6 probability that this sample mean will come out to 35, because there's 2 ways for it to happen, right? If these two people are chosen, the mean is 35. If these two people are chosen, the mean is 35. So 2 out of 6 possible samples have a mean of 35, right? There is a 1/6 probability that the sample mean will come out to 40, because these two people have to be chosen for the mean to be 40. There's also a 1/6 probability that the mean will be 45, right? Because it's one box with a mean of 45 out of 6 boxes, right? So let's review what I just said. The numbers that the sample mean could come out to are 25, 30, 35, 40, and 45. The sample mean has to come out to one of those numbers. And the probabilities are 1/6, 1/6, 2/6, 1/6, 1/6. Let's move on to another example. Here we have the same population, but now a random sample of 3 people are being selected. The ages are being recorded, and the mean of the 3 people is being calculated. Once the 3 people are chosen, this person is going to add the 3 ages and divide by 3 to get the mean of the 3 selected people. In this situation, there are 4 possible samples, because persons 1, 2, and 3 could be the chosen 3. Persons 1, 2, and 4 could be the chosen 3. 1, 3, and 4 could be the chosen 3. And here's our last possible sample of 3. So one of these possible samples will become the actual sample. Remember that in a sampling distribution, you're looking at all of the possible samples, but only one of them will become the actual selected sample. Right over here, the person is selecting 3 people, so the 3 people who were actually chosen could be this, this, or this. And once again, we've just plotted each possible sample above its sample mean. Here, in this first box, we have a 20-year-old, a 30-year-old, and a 40-year-old, right? And if you add those 3 ages and divide by 3, you get 30. We can use this sampling distribution to get the probabilities of each possible outcome, right? So the sample mean has to come out to one of these 4 numbers down here. And the probabilities are 1/4, 1/4, 1/4, and 1/4, because there's 1 out of 4 possible samples with this sample mean, 1 out of 4 with this sample mean, 1 out of 4 with this sample mean, 1 out of 4 with this sample mean. So these numbers down here are all equally likely. They all have a 1/4 probability of happening in this situation. Let's look at a couple more examples. Here, we're taking a random sample of 2 people from this population. So we have more possible samples because there are more combinations. In this situation, there's 10 combinations of 2. And I plotted all 10 of them here. Once again, it's just the 2 people above their sample mean, right? Add these 2 numbers and divide by 2, and you get the sample mean down here. In this situation, these are the numbers that the sample mean could come out to. And the probabilities are 1/10, 1/10, 2/10, 2/10, 2/10, 1/10, 1/10. So there's a 1/10 probability that the sample mean will be 15, a 1/10 probability that it will be 20, a 2/10 probability that it will be 25, a 2/10 probability of it coming out to 30, and so on. Here's another situation. Here once again, we're taking 2 people from 5 people, but the population has changed. The population is now a 20-year-old, 3 30-year-olds, and a 40-year-old. So the shape of this diagram has changed a little bit. And now the probabilities are 3/10, 4/10, 3/10. Here we have one other situation in which 3 people are being chosen from this population. And now the sampling distribution has become flat. So it looks like there's 9 possible samples and 3, 3, and 3. So the probabilities are just 3/9, 3/9, 3/9, or you could simplify and they would be 1/3, 1/3, 1/3. So before we go any further, I want to try to relate this to a more real life example, or not really a real life example, but just something less imaginary, something more real. So imagine that we're back in class and I put all of your ages into a hat. It doesn't have to be ages, but let's just say that I'm recording ages. And I randomly pick 3 people out of the hat. I write down the 3 ages and I get the mean of the 3 people. I add and I divide by 3. And let's say that I want to know the probability that my sample mean will come out to 19.5. I want in that situation, I want to know the probability of me randomly selecting 3 people from the class and getting 3 people with a mean of 19.5. Well, to get that probability, what I would have to do is go around and calculate the mean of each possible sample of 3 people for every combination of 3 people that I might choose, and then count the number of possible samples with a mean of 19.5, count the number of ways it could happen, and then divide the number of possible samples with a mean of 19.5 by the total number of possible combinations, and I would get my answer. That would be a lot of work, and because there's so many possible combinations of 3 that could be chosen from our class, because it's 3 out of 45 people, right? So that would just be a really long version of what I'm doing here on the screen, right? There would be many more boxes in the diagram, but it's the same idea. So let's go over the steps of creating a sampling distribution with a small population. I'm just going to show you how to do the work that I did on the screen in a step-by-step way. So you could actually create your own diagram if you want to do. So what you do first is you list out all of the possible samples, all of the possible combinations. Then you calculate the statistic of each possible sample. The statistic might be a mean, it might be something else like a standard deviation. It just depends on the situation you're dealing with. But you calculate it for every possible sample. Then you organize the statistics that you've calculated in a list or a graph, and that's your sampling distribution. In the examples that I've already shown you, I've organized it into a graph, but it could also be in a list also. So let's do one example of creating a sampling distribution with a small population. So now we're imagining that a population of 4 people have these ages right here. The ages are 20, 22, 24, and 26. A person is randomly selecting a sample of 2 people from the population, recording their 2 ages and calculating the mean age of the sample. This is the same type of situation we've been looking at all along today. Over here, we have our population of 4 people, their 4 ages. What I've done over here is I've listed out every possible sample of 2 people that could be chosen. So when the 2 people are randomly selected, these 2 people might be chosen, these 2 people might be chosen, or maybe these 2 people. I'm going to show you how I got these possible samples. What I did was I started with person 1 and person 2, then I went to 1 and 3, then I went to 1 and 4. So 1, 2, 1, 3, 1, 4. That gave me these first 3 possible samples right here. Then what I did was I moved down to 2, and I did 2, 3, and 2, 4. That gave me sample 4 and sample 5. Then finally I went to 3, and I paired 3 and 4. That's the last possible sample. So if you're selecting 2 people from a population of 4 people, what you do to get the possible samples is you start at 1, and you pair 1 with everything below 1. 1, 2, 1, 3, 1, 4. Then you move down to 2, and you pair 2 with everything below 2. 2, 3, 2, 4. Then you move down to 3, and you pair 3 with everything below 3, which, well, 4 is the only number below 3. That means that 3, 4 is the last possible sample, right there. So write 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. Now that what I did after I found out what the combinations are, I filled in the ages from the population, right? For example, person 1 and person 2 are ages 20 and 22, right? Person 1 and person 3 are ages 20 and 24 from the population. Then I calculated the mean of each possible sample by adding and dividing by 2. So for sample 1, I added and divided by 2. For sample 2, I added and divided by 2. I did it for all 6 of them. Then what I did is I listed out the 6 answers over here. My 6 sample means are here. There's 1 for each of the 6 possible samples. And that's my sampling distribution. Now I can go one step further and turn this list into a graph like the ones I was showing you at the very beginning of the video. So let's do that. Over here we have our sampling distribution. These are just the 6 sample means from that list on the last screen. they are the 6 answers that I calculated. So person 1 and person 2 have a mean of 21, person 1 and person 3 have a mean of 22, and so on. The highest one is person 4 and person 5 with a, no, I'm sorry, person 3 and person 4 have a mean of 25 right here. And we have our probabilities. In this situation right here, the probabilities are 1/6, 1/6, 2 over 6, 1 over 6, and 1 over 6. So yeah, and I also made a graph of the 4 population members up here. Now, I wanted to mention something. If I give you a problem like this, I won't ask you to actually figure out what the possible combinations are. So what I would do is I would provide all of the combinations to you and just have you fill in the blanks with the ages or whatever the data values happen to be, and have you calculate the sample means. So I would tell you that these are the combinations and just have you fill in the data and calculate the answers basically. I think that takes a little bit of the difficulty out of it. So here I showed you the probabilities. This is the same diagram, but with the probabilities labeled. Here we have a situation in which 3 people are being selected from a population of 4 people, and the sample mean is being calculated. So someone is randomly selecting 3 people from this population and calculating the mean age of the 3 people. So we have our population right here. We have our possible samples. We got the mean of each one by adding and dividing by 3, and we listed out the answers over here. So if sample 1 is chosen, the mean will be 22. If sample 2 is chosen, the mean will be 22.7, and so on. Like I said, it's like spinning a spinner, right? It lands on one sample, which becomes the actual sample. And here's our diagram. And here's the probabilities. They're all 1/4 because, well, each one shows up one time, and each one is 1 out of 4 possibilities. Now let's do one example that doesn't, in which a mean isn't being calculated. Let's do an example with a different statistic being calculated. So in this example, we have a population of 4 people with these genders: male, male, female, and female. Actually, I'm going to do this example in the next part of the video. So I'm going to stop this video right here and begin recording again.